Thank you for the introduction. So, as the title suggests, I'm going to tell you about what I've learned in my career so far as a data scientist at 3 different companies in terms of how to actually engineer data products. So not just build a model or, build a model, a data science product that's going to be used to gain insight or to show to management, but how to actually build a product that will go out to a client, be it internally in a company like Migros or Credit Suisse, or be it a product that actually goes out to the user on the internet or something like that. So for me, just to know a little bit, how many of you work as a data scientist right now in industry? Okay. And how many of you are not a data scientist, but you're in IT? So you're a software engineer, IT person? Cool. Okay, so I hope both of you will learn something in this talk. So shortly, again, about me. She already said most of the things about me. I just want to explain a little bit. So my background, I would say, is pretty typical for a data scientist so far. I got a master's in physics at ETH in Zurich. Then I did a PhD in neuroscience. I spent almost 10 years doing research in a field called neuroinformatics, where I not only had to use statistics and machine learning, but I also learned to program. I learned to program in MATLAB, which is not a real programming language, but still, it taught me how to write a for loop and implement machine learning. And then once I decided to switch to data science, I converted to Python, which was a little hard. But once I did it, I never looked back. So that's my background. So when I started as a data scientist, I learned about the basic data science workflow that you've probably seen. So you get the business problem, and then you form a hypothesis. Then you build a model, you test and iterate. This takes a lot of time. You know, you have to do data cleaning, all this stuff. You have to use the right metrics. Finally, you're done with it. What are you going to do? You're going to deploy, right? Right. No. Not happening in most businesses I've worked in, right? Because suddenly everybody's like, oh, where is she going to deploy it? Which language is it going to be in? Et cetera, right? So it usually stops there. And one of the reasons for that is that a data science product has many more layers than just this data science workflow that we've just talked about, right? So yeah, sure, you start with the business problem, business understanding, but there's probably a lot of work going into the data acquisition and understanding. Then, of course, there's the modeling, which is your expertise as a data scientist. And then, last but not least, there's the actual deployment, right? So you see, and all these components interact, right? Because to deploy your model, it has to have the right language that you can actually deploy. It also has to be fast enough. It has to, and the modeling actually has to also understand how the pipeline works that actually processed your data. So all these components have to play together. Now, that's you. If you're trying to become a data scientist, you've probably seen this. So that's all the things you're supposed to know. Let me tell you, that's not me, OK? But anyways, as you know, every data scientist is supposed to understand math and statistics, programming in databases, domain knowledge, soft skills, as well as being a great storyteller, right? So that's already impossible. But now, you haven't solved the engineering challenge yet, because just because you understand databases and you can program, still, it's not going to go into production, right? So usually what you need when you have a data product is you need a team or a person who's like the product owner or the product manager. You probably, if you have a front end, you even need somebody who has some user experience knowledge. Then there's you or your team with the data science skills. And then there's the actual technical delivery team or person. Or they think you're going to do it, but hopefully there's somebody else who's going to help you at least. Right? So this is the complexity of a data product. Oh, OK, let me go back. No, it's fine. So some companies thought, because of this, it's a great idea to find a data scientist who also knows about the big data tools. right? So they're going to list a bunch of skills, like Spark, right? HDFS, Hadoop, all this stuff. So yeah, it's a futile exercise, because this is the big data landscape 2018. So nobody's going to know all these tools, right? So what's the solution to this problem? Well, I'm not the only one. Like, there's online a lot of blogs about this and consultants talking about this. Probably the most likely solution right now, at least, is this. You take DevOps and data science, and then finally you have your unicorn. Right, so what's DevOps? DevOps is development operations. And it's more like a movement that started around 2007, 2008, where in the traditional software engineering space, people realized it's really bad to have developers separate from the operations team. So they started putting these two together and combining it. And it has made a lot of progress for a lot of companies. So a lot of companies are switching to this model. And so now what we need to do is break the next barrier, so not only between development and operations, but between development, operations, and data science. Because if you're separate from that DevOps team, it's still not going to work out. So what does the DevOps team do, right? So they care about the deployment, the development, as well as the operations, and they worry about things like quality assurance. So I remember the first time I sat in a meeting about a data product, and they started talking about non-functional requirements, and I didn't have any clue what they were talking about. So by the way, that's a tip. So it was me and, of course, only male people in the room. And so I just didn't say anything. I just nodded. And then afterwards, I went and Googled it. So the next time I came into the meeting, I knew what they were talking about. So they worry about this stuff. So they want to know about the efficiency, the quality, the response time, availability, interoperability, security, of course, fault tolerance, and documentation. So that's what they worry about, okay? Me as a data scientist, I couldn't care less about these. But I have to help them, because if I'm not going to help them, and we're not going to pass all these tests, this product is not going to go into production, right? So there are the functional tests and the non-functional tests. The functional tests are actually the ones that me as a data scientist, I'm even partly responsible for, right? Because they're testing the functions that I programmed into this data science tool. So I have to worry about unit testing. Smoke testing is testing the whole package. Integration testing is testing this package with all the other packages that are already there. System testing is testing the whole thing. And then, okay, the DevOps guys hopefully are going to take care of all the non-functional tests, but I still need to know what they're talking about. For example, load testing will depend on how I actually coded the prediction model, right? So there's lots of interactions here. So this is what can happen, right? So the data scientist says, I'm not able to replicate this issue. This is working fine on my machine, so close the bug. The DevOps person says, I don't care if it is working fine on your machine. We are not going to deliver your machine to the client, right? So this is very often what happens. So why does this happen? Well, part of the reason is that data scientists like myself, they write spaghetti code, okay? So what's spaghetti code? Spaghetti code is code where the relations between the pieces of the code are so tangled that it is nearly impossible to add or change something without unpredictably breaking something somewhere else. It's not going to pass any testing. And also, your fellow data scientist who takes over your project, poor person, is going to have to throw it all away and start from scratch. So what can you do as a data scientist? And I encourage you, if you are a data scientist, is to start learning how to write production-level code, okay? So unfortunately, if you actually want to write code that anybody else is going to use, you have to at least understand these concepts and try to implement them. You don't have to be perfect at them, but at least give it a go. So write your code modeler, right? So if you copy-paste your code once, you write a function. And also, you package it in a way that functions that belong together are in the same module, etc. You also have to implement some logging, because if something goes wrong, nobody's going to figure out what's wrong unless you do this. You should actually optimize your code a little bit at least. You should write unit tests. You should also use a version control, like Git. You have to make sure your code is readable. So in Python, there's pep8. You can just read the rules and follow them, how to write comments, how to name your functions. And also, you should actually do code review. Now, this is hard if you're a single data scientist somewhere, because there's nobody who's want to review your code. But hopefully, there's at least one other person. And also, tip there, if you have a very senior person, make sure you don't bug them too much. So prepare the code, make it nice and clean, and then ask them to do the code review, give them enough time, because nobody wants to code review everybody's spaghetti code. Yeah, so about the Git, maybe you've used it before, but what I mean is not only know how to commit, but also understand workflows. So don't commit to master right away, but make a branch, all this stuff. So it's really useful skill for data scientists. There's lots of tutorials out there if you need some help understanding that. Then another aspect that also I find very important to understand also with data science products is that it's really useful to also adopt the agile way of working. So that means instead of doing a long project like you did maybe in academia or in research, you actually build a model. You can use a framework like CRISPR-DM, which is like a framework for data science workflows. But then you do it iteratively, right? You do it one time, end to end, and then you refine it, and then you refine it again. And I believe that the right framework to do it, or the right methodology, is Scrum. So Scrum has been around for a long time now in software engineering. And I believe, like lots of people, I hear lots of data scientists telling me, oh, this doesn't work for data science. Let me tell you, it works for data science just like anything else. So it's just an excuse. So my suggestion is you learn about the methodology. The nice thing about it is it has very clear rules, so it's nice. It has a nice structure, and yeah, you can work very effectively with all the other people on the team, like IT people, engineers, etc., and actually deliver the product in time and iteratively, so that the business actually sees the impact that you have with the data science project. Yeah. So the conclusions is, you can't do it all on your own, and learn from software engineering. And I would also say learn agile methodologies. And one last thing is document. I know nobody likes to document, but it's the worst if you come somewhere, some data scientist made a great model, nothing's documented, you're not gonna be able to work with it. Thank you. Just before the questions, I want to thank Sandro, who works at Migros too, who made the slides. And I also want to mention again this Women in Machine Learning Data Science meetup group in Zurich that we've been doing since 2017. I need co-organizers, so if you're in Zurich and you would like to co-organize, come talk to me. Thanks. Questions?
Hello, thank you for the presentation. Now the question doesn't relate to the presentation, but as you are coming from Migros and you are their data scientist, I would love to hear which is one of the use cases, the most excited use cases that you have worked on, if you could provide some details on that. Yes.
Yeah, high level I'm allowed to say. I'm not allowed to talk about it in detail. Yeah, I work on a pretty exciting project, a data product. I like working on data products, so it's actually a front end that our people can use to plan promotions. So Migros, of course, does a lot of promotions, and the tool is helping to figure out whether it should be 50% on strawberries this week or 30% on apricots next week.
Hi, thank you for your talk. My question is on the using Agile and Scrum in data science. I agree that it should be used as well, and the comment that, or sort of the complaint I get from my data scientists often is on more exploratory tasks and how to estimate them, how to define them if we don't really know, and we have had success working with time box tasks, but I was wondering if you had any insights there.
I don't have specific insight, unfortunately. I agree that this is a little bit of an issue, but I don't really see the issue. I think people are just not comfortable to leave their way of working so far, because even exploratory stuff you can put in a 2-week sprint, right? You just define the user story as explore the data.
Yeah, you should probably define better success criteria, I guess.
Yeah.
Thanks.
Hello. I have a question which is very controversial, I think. How acceptable is it to write the spaghetti code when you are developing a proof of concept?
If you're working on it on your own, I would say it's fine. But what are you going to do if the proof of concept succeeds? You're going to have to rewrite the whole thing. Right. But then that's on you. As long as you don't bother anybody else with it, I would say it's fine.
Okay.
Just back on the Scrum point, given the chance to do your PhD again, would you do it in Scrum methodology?
Well, my PhD was a little different. It was an experiment that lasted like 3 years. So I guess you could, but not Scrum, but you could still do it more iteratively, right? Just not 2-week sprints. That's crazy. Yeah.